A classic application of vector integration is the equations for projectile motion in physics. So the scenario is we've got a projectile is going to be launched from 0, 0. It's going to be launched at some angle alpha, and I'm going to denote our unit vectors here by I and j. So I is horizontal motion parallel to the ground. J is a vertical direction. So this is a 2D instead of 3D situation. And we want to find the particles, the projectile's position at time t. So, and what we're given is just its initial velocity. So the initial velocity will be, well, let's say the magnitude, so the speed, this is the initial speed, times cosine alpha I plus initial speed sine alpha j. And let's define v0 without the hat to mean the length of this. Then this is the initial speed. Then this becomes just v0 cos alpha I plus v0 sine alpha j. Then from physics, we know that the acceleration, which is d squared position over dt, will just be negative gj, where g is the force of gravity. Which is approximately 9.8 meters per second squared. So to find the position, we will integrate the acceleration twice. Exit space. So this is our v0. Okay, so v of t is integral from 0 to t of acceleration s ds. This is acceleration. So that will be negative gt j t0, which will just be, negative. So s is like the variable. So we're substituting t into s, but then this becomes just, negative gtj plus a constant vector c. And we have that, so v of 0, so then v of 0 is going to be just c, and so we get that c is this. So our expression for the velocity at time t is v0 cos alpha I plus v0 sine alpha minus gt j. So now to get the position, we will integrate this again. And so our initial position is is 0, 0, so we won't have to have a constant there. So position time t will be integral from 0 to t of the velocity. Sorry if there's a lot of background noise in this video. 0 to t vs ds, so that will be integral 0 to t of this, and that'll give us v0 cos alpha ti plus v0 sine alpha t minus gt squared over 2j. So this equation, we call the equations of ideal projectile motion. So let me do an example. So let's say a projectile is launched at 40 meters per second at an angle of 30 degrees from horizontal. And we want to find its position at time t. So our equation is r of t is v0 cos alpha t I plus v0 sine alpha t minus g t squared over 2j. And our variables are v0 is 40, alpha is 30 degrees, so cosine alpha will be root 3 over 2. Sine alpha is 1 over 2, and then and g is 9.8. Let's just say 9.8. So v of t, or r of t, will be given by, this will be 20 root 3 times t in the I direction, and then plus 20 t minus 9.8. So 9.8 over 2 t squared j.